Okay, so now what today's session will continue with a little bit of introduction to robots in general, not just industrial robotics, so that you can have some prerequisites, some knowledge what exactly is a robot, what do we mean by saying when we say a robot. Okay, so that will be discussed here, and some laws of robotics rather, so that we'll discuss that, why that is important, why that laws has to be there in your brain all the time while we work with any robot. Okay, a timeline, how it has evolved. You must be feeling why these things are important to you. Yes, a few of you might be applying abroad, some of you might be trying for UPSC. Nowadays UPSC also has syllabus that includes industrial robots, so that is why it is important for aspirants like them. And yes, in general you should be knowing this, so that is why it is here. Thumb rule for the decision of robot uses, this is very very important. When you should choose a robot, what type of robot you should choose for a particular application, so this is very very important, which is there in this particular module. Applications of robot, different applications we'll discuss. So till module 5 we'll cover today. Okay, and then we'll move further in next class. Okay. Okay, so what exactly is a robot? Where did this term originated? Most of you, quite a lot of you probably know where it is originated by now, because seeing your curiosity, hopefully you have gone through different Wikipedia and videos all around. Okay, but formally, robot is an automatically operated machine that replaces human effort with or without human resemblance. That means your notion of having a Star War type of robot, okay, so that goes here itself. Okay, with this first definition, which is very very formal, that means it may not look like a human at all. It can be just like an arm, human arm, or sometimes it is not even a single moving part. That also can be a robot. It can be just a screen with some animated creature which is coming on it, like an avatar. Okay, that also is a robot. Sometimes web bots are also there, you must be there. With those definition formally cannot be put into industrial robot as such. Industry, you see most of the physical things which are there, so that definition in industry may not be that equally good, but yes, that is how a formal robot is defined. Then comes the concept of artificial human that predates any recorded history. Okay, actually, robot, how it has evolved, it has evolved long back. Okay, it predates to any recorded history. It has come, even we don't know when it has come. Okay, probably in some old drama or somewhere it has come. Formally, yes, it has been documented that most modern term robot, the modern term robot that we use normally, was derived from a Czech word robota. Robota means a forced labor or a chef. Okay, it is used in Karel Capek's play RUR, that is Rosarum Universal Robots. That was a 1920 play. So quite a lot of inventions happen because of fiction stories, sometimes through some drama. Okay, so that is how this also was conceived to human. Okay, the word robotics first appeared, robotics, not robot. Robotics first appeared in Isaac Asimov's science fiction movie that is known as Runaround, that was evolved in 1942. Okay, and then come Runaround contained some famous laws of robotics. Those were formally established and known as three laws of robotics. So you see, a movie has given a formal definition finally. So what is laws of robotics? Asimov's three laws of robotics. First, it says a robot may not injure a human being or through its inaction allow human to come to harm. Okay, allow any human to come to harm. Okay, so what does it signify? What does it mean basically? A robot should be built, uh, its brain should be such that it doesn't accept any command comes later in this, but yes, it should not injure any human which are around. That is first thing. You cannot make a robot which kills a human, so then it doesn't fall under the category of human altogether. Okay, so that is the first. Then comes, a robot must obey the orders given it by human beings, except such orders would conflict the first law. Again, this particular definition follows the previous one. That means a robot obeys human command, but if a robot is commanded to kill another human, it won't follow that. Or you cannot ask the robot to kill yourself also. Command that yes, you kill me. That also it should not accept. Okay. Then comes the third one. Robot must protect its own existence as long as protection does not conflict with first and the second one. Right? It will protect itself. While protecting, it should not kill the commandant. Okay, so the commander, that is you, the programmer maybe. Okay, so all the three laws comes chronology is first, second and the third. So second law supersedes the first one while it follows the first one. Similarly, third one should follow the first and the second one. So you got, so first one is robot may not injure a human, that is the crux of that. Second one, it can be commanded, but it cannot be commanded to kill some human. Third one, it can protect its own existence, but again, while protecting itself, it should not kill you or anyone who is around, any human around. So it is only as a slave of human, not slave of a person. Got it? So these are famous three laws of robots. Then comes timeline, how it has evolved. The first stationary industrial robot, I am calling stationary industrial robot. It looked like a robot. Okay, the way it is there in the industry, I'll probably show one small robot here. So this is a small robot which I have next to me. So it looks like a, it doesn't look like a robot at all, a humanoid maybe. So what it is just an arm. Okay, you can move it, it has some accesses, it picks a object from a place and it puts it somewhere else. So this is how it is. This is how it is. So what it is a stationary robot and it is programmable, and the first one which was of this kind is first developed by Unimate, that was Unimate, and it was a stationary robot which was very much like a human arm. Then comes, it was invented in 1954 by American engineer George Devil. Later on, it was developed by Unimation Inc. That's a company founded in 1956 by American engineer Joseph Angelberger. So although Angelberger is known as father of industrial robots. Okay, this is not a mobile robot, this is not an underwater robot or a drone. This is industrial robot. This is how it is there in the industry, mostly arms. Nowadays, it can be some other forms. I'll show you, discuss with you that as well. The first prototype of such robots was introduced in 1959 by at General Motors Corporation as a die casting factory in Trenton, New Jersey. Got it? So that was the first commercial one. And world's first production line serial robot. Why it is serial? You saw it is just like of our arm. Okay, so it has an shoulder joint, it has elbow, it has uh, uh, wrist joint, some fingers. So it is serially connected and it terminates. It is not a closed loop, it is not a 4-bar mechanism. It is just a serial chain, just like an open loop chain, and it is very much similar to that. So this kind of robot, serial robot, was delivered to General Motor Factory in 1961 by Condac Corporation. What is Condac Corporation? It is nothing but an acquisition of Unimation Inc. only. Okay, so where we should apply robot? These are some of very well posed question and quite often asked to we people, where we should use this. Can we use it anywhere we feel like? Should we use it first of all? So mind it, normally we prefer using it for dirty task, any task which is dirty. These are known as 4Ds. Dirty, that means something which is very dirty. While doing a forging operation, for maybe some machining operation, or sometimes during a casting factory, sometimes in painting. I'll show you some applications also. So painting is a very dirty task. Okay, if you paint it, you yourself get dirty. So that may be one, buffing, polishing, and those type of tasks which are dirty in nature. Or a dull work. Dull work means um, as soon as you joined on to your duty, what you did whole of the day, you were just picking up some object from the conveyor and put it into to a carton, and you put it to the other conveyor, it moved off. So let us see, if you get to do such a task of such repeatable task, then what will happen to you? You will fill with a fatigue. Okay, your whole of the day you did nothing, you just picked up an object, put it somewhere. Okay, so that is very dull task. Sometimes tasks are dangerous also. What task could be dangerous? Let us say you want to invest, just a simple, very simple task. You just have to navigate a area which is filled up with nuclear radiation. Some plant has broken or something like that. So what dangerous is there? You have the chances of getting radioactive radiation, no? So that is a dangerous task. Maybe a fire hazard is there. Factory is filled with fire. Now your robot has to go and rescue someone. So that is dangerous task. There are many other industrial dangerous tasks also. So that could be one application, dangerous and then difficult. Sometimes in factory, you don't just lift a object which ranges from 0 to 1 or 2 kgs, which we are quite familiar with and we are quite conversant in doing that. Right? In that case, an object can be more than 5 kg of payload. 5 kg. In that case, it is not very convenient. A single person can't do that particular of loading whole of the day, or maybe even for 1 minute if it is more than 20 kgs. Okay. So these are some difficult tasks. Just one example. Difficult task can be a simple 5 kg payload in a hot bath, near to a hot bath in a steel industry. So that itself is a difficult task. So, these 4Ds should be there so that you choose a robot to do your task. Then robot may not leave human jobless. This is first concern. You have plenty of human all around and they are inexpensive also. You should not look for a robot. That is not just ethical thing that I am talking about. It has some secondary consequences. We'll discuss that as well. Whether one can find the people who are willing to do same job, then you can find plenty of people who are ready to do that job. So you should not seek for a robot who should do that. And then it must take, it must make short term and long term economic sense. Short term and long term, that means immediately you are not paying hugely for that particular robot, or over the year you are paying it for the maintenance aspect of that particular robot. So this short term and long term, it should be economical to the industry. Not just precision which matters. Yes, it does matter. If at all it is so precise, then it is a difficult task, so it falls under the 4D category, right? So that is a difficult task. Then I'll just discuss some application which are in general, which is there in industry, without going much into general applications which are there as a robot. I'll immediately show you a small video which shows some of the application. Okay, so this is a standard video which is quite easily available over YouTube. This is just one of that. So you see, it is in industry, it is arc welding for precise welding, repeatable welding. Spot welding, spot welding where two plates are joined together or a frame is joined with the car chassis. Material handling, picking an object from a place, putting it somewhere else. So that is what is being done here. Machine tending, yes. What happens, you pick a tool, put it to a machine which does machining. So that tool can be placed in the cutting tool. It can be a cutting tool or something like that. Okay, it's a painting task which is done. This is quite common in the industry. You see it, how dirty it is. Picking, packing, pelletizing, it's a repeatable task. Again, it is very, very monotonous. Got it? It is pelletizing task and assembly. This is one of the very less seen in the industry. This is assembly, when two or more parts they are made together and they are probably welded or assembled using some fixture, laser cutting and all. Okay, so these are some of the common application which is there in the industry. This is grinding, this is polishing, gluing, adhesive, sealing. They do it quite uniformly. See, this is spraying. Other processes are also there. This is assembling of in PCB. While machining, it can do something. Yes. Electronic assembly, PCB assembly. That's all. So you see, these are some of the application which is there in the industry, primarily in the industrial shop floor. Otherwise, it can be used as a medical robots, which is a typical medical robot is Da Vinci robot, which is very, very popular, though there are many others for specific purposes. It is also used in mining. You see, it is Julius mining robot. What it is doing, it is picking up sample, doing some surveying operation underground. NASA space robot is there. Not just NASA, there are many other space stations which has special robots. What it does, it has a huge boom. It is sometimes used to dock two space shuttles together also. Okay, so you must have heard of this. Underwater exploration, Discovery Channel and those channels, they show this quite often. Underwater exploration. This is Daksh defense robot developed by DRDO India, Pune only. So what it does, it simply is used for defense, developed by DRDO, mainly used as a bomb diffuser. UAV Netra, maybe it has covered in some of the movie also. It is nothing but a standard drone-like creature which does cross-border surveillance. So both of these are developed by DRDO. And then rescue operation, Thamsup is a company which is in Japan. They do rescue operation. It uses a standard earth moving vehicle, and they have automated the arms so that it can be used for rescuing. Sometimes people get trapped in a ice, so that is what is shown here. Then agriculture robot, over here it's a Bosch one, which is very, very popular. They are really very fast in seed sowing, cutting, harvesting and those things. These are some of the standard application, although they are not very much into industrial robots are mostly the fixed one. Nowadays you see also mobile robots in warehouses and all. Okay, and this is a domestic robot which is shown here. What it does, it simply does some service operation at home. Maybe it takes care of elderly people who are there at home. When you may be going for a job, elderly people, they stay at home, so it can take care of that. It can take care of kids at home. They at least entertain people, right? And it can be used as a security surveillance also. Maybe while you are sleeping, this domestic robot can be awake, right? So entertainment, that is gaming platform. Quite a lot of you are quite fond of gaming also, I know that. So this is one which is developed by me only. That's a gaming platform where I am sitting driving. It is like a driving simulator. Bottom you have a platform which is very much like a parallel robot. I'll show you that also. Automobile industry, just now you saw in the video, it was doing some spot welding operation. And then comes, there are many innumerous applications. You just saw material handling, palletizing, packaging, processing. You have seen welding, spot and art, surface finishing, that is polishing, buffing, grinding, deburring, painting, machining and drilling operation, assembling, yes, collaborative robots that does assembling, that needs some sort of compliance also. That is a special category of robot which are nowadays known as cobots, which has many other features. While we'll be doing kinematics and dynamics, we'll again come back to this type of special robot, which will give you some special insight about this type of robot. Okay. Okay, so now I'll get into what exactly goes into defining a particular industrial robot which you saw just now. What all things that make up a industrial robot. It is not in general, it is not just for a serial robot arm, it can be for any industrial robot. So how it is made up of? I'll switch on the camera once again for the serial robot thing. This is how it was. So it has a arm, that is number one, which is mentioned over here, that is number one. And then it is controlled using a bottom thing, that is this one which you can see. This base has got a controller. In industry it is a different one. In industry it is nomenclature as 2, that is what is the controller, or you could see that is the controller which has a software which is there inside. Everything for a domestic robot, for a tabletop robot like this, it is there down below. Got it? Then comes, this is the controller, and on top of this there is a teach pendant. What it is used for? It is used to program a robot. It is used to program a robot. For domestic robot and tabletop robot, programming can be done using a desktop PC. But in case of industrial robot, it is a teach pendant. It has a long wire which can be dragged till the robot end effector, and then you teach it. You take the robot to a place, teach that location, and then again you teach another location, and then trace whole of the thing. That can be done. That is used for teaching, sometimes for programming also, jogging operation, calibration operation, testing operation, everything can be done using that particular thing. So we'll talk about detail about teach pendants later on. And then it is constructed, it is. Sir, suppose the equipment has joystick attached to a teach pendant, that can be considered as, yes, it is normally attached. I'll show you my teach pendant in detail just after this slide. Please wait. So that has a 3D joystick, a 3D mouse type of thing, which is used to jog your robot to XYZ roll pitch yaw, 3 translation and 3 rotation. That is a 6 degree of freedom mouse. So that is always there with the teach pendant in latest thing. Okay, so that is there over here. Okay, so connecting cables, it connects different things together. It connects the sensor, it connects the powers, it connects the signals. So those are connecting cables. It can be a pneumatic cable also, which supplies pneumatic supply to end effector. Professor Jaffer, he will discuss much more in detail while he will be discussing pneumatics and hydraulics in detail during automation portion of your syllabus. So we'll again talk back to this when we'll see how things are integrated together in pneumatics and electronic things. Robot over here is an electrical electronics, but yes, quite a lot of things are compliant, and those things are pneumatics. He'll talk in detail, don't worry, he'll come back to this. So you also have some pneumatic cables. Okay, so that also is there, and you have plenty of actuators which needs power, which has signals. So those things are there. Number fifth is end effector tools. End effector tool can be polishing tool. Just now you saw in the video, which can do polishing, which can do grinding, it can do spot welding. So tool differs from application to application, right? Over here in fifth number, you see it's a two-fingered gripper. Just a two-fingered gripper. It has nothing else, just a two-fingered gripper. So that is known as end effector tool. By default, robots are not delivered with that tool. It is delivered just with a flange. you can attach different types of tool depending on application to application, right? So that is what is a tool. And then comes software for the controller. Software for the controller, just the way if you have installed a mouse that requires a driver, so robot becomes a device, and this software to run this robot has to be there in the controller, okay, in the hardware controller, which has some insights also. I'll show you opened up controller, don't worry. I'll open this box number 2, that is the controller box. I'll show you very much in detail inside also. So that has a regular PC which installs this particular software, which has a GUI to control all IOs and the robot itself. Even the programming language is there. So optional accessories can be, by default these are not there. It can be a camera. It can be a camera which can allow robot to see something. But yes, it doesn't. You just don't expect that. Yes, not the camera is there. It becomes just like human. This robot has a camera. Yes, now it can pick up anything just by watching at it. No, you have to integrate things. You have to create some code which takes data from the camera, and you have to do some output coding so that it can do gripping function. Okay, so these things are to be related through robot programs. That is not just a device which it, if it is attached, it does the thing. Okay, similarly you can have an external access. External access may be a table, a rotary table where you can mount a tool, an object which is to be machined, which can rotate along with the table, and robot works on top of that. That can be done. Sensors, external sensors can be there. It can be a proximity sensor if you want. Nowadays it is there by default, plenty of sensors which are there. Some of there are implicit to the robot, some of there are explicitly attached to the robot, like safety sensors. Your robot is there in a grill. Normally they are in the industry. Okay, so as soon as you enter into that cage, robot is slowed down or it is stopped completely. So that is through external sensor. These are optionals. These are optional. Yes. Now I'll discuss very much in detail what things are there. So just now I showed you a few. This is what? This is your two-fingered gripper. This is a shunt make. It is attached on top of a robot flange. But yes, there is something in between. This is what? This is a load cell. A load cell. What it can do? It can feel the forces that comes on the gripper. This is not a regular attachment. This is for a special purpose robot. It is there. It looks like this, right? And then these are the actuators. These are the actuators, rather the motors. Motor with the gearbox and the transmission is known as a actuator. We'll discuss actuator very much in detail in the next module. That is actuator. This is the top box where you have some valves which are fitted. So blue wires, all the blue lines are pneumatic lines. So this is a pneumatic gripper. So all the valves to operate that pneumatics is over here. Whereas the black cables that you see is nothing but that is electrical cables. Those are electrical cables. And then you see there are green cable which is here, that is communication cable. So each cable has got some color coding which is there. This is your controller. This is a standard industrial controller which you can see. On top of this, this is a teach pendant. I'll show you very much in detail once again. This teach pendant, this is a extension cable. Got it? Okay. So now I'll expand this teach pendant. Just now you saw that. I'll show you where you just asked now. This is a 3D mouse. This is a 3D mouse. It is used to jog the robot in 3 translation direction, that is X, Y, Z, and rotation along those 3 axes. So this is nothing but a 6-DOF mouse. This is emergency stop button. This is mode change for programming. For regular run you can change. Standard programmable button. It can be fixed programmed button which comes along with the GUI. So few of them can be programmed button. It shows X, Y, Z, plus minus plus minus plus minus. So it is very much like this. And then code editing, stopping, running code backward. It shows some information. It is very much like a computer display. It is nothing but a replica of the PC which is sitting inside the controller. So it is just the same screen. It can even show the directory structure of the files which are there. These are your codes, they are your programs, computer programs. These are some of the programmable buttons. So you see very much in detail now. You know how does a teach pendant look like, and it has at the back of it, it has some safety switches. If you grab it, then only it will run. If you throw it off, it will immediately stop the robot. I'll show you that picture as well sometime later. This is a standard two-fingered gripper. This is how it looks like. It has some pre-built sensors which tells the robot, yes, now it is closed or it is open. This is what is an external accessory, external access, where you can mount a object, fix it over a vise, and this motor runs synchronous to this whole of the robot. Got it? So this is there always, not always. This is an optional accessory that can be there. So this is how a typical robot and its subsystem would look like. This is an industrial robot. This is a arm, a serial robot. It can be a parallel robot also, but the controllers that I have shown you, it has similar structure, same type of things will be there. Even if it is a parallel robot, it will have a gripper, it will have a controller, it can have a teach pendant. Teach pendant is not always mandatory. Once the robot is programmed, you can take it out, you can put it to other robot which is not programmed. In industrial assembly line, you find more than hundreds of robot all one by one. Just now you saw that in the video. Got it? So you can program one of them, take out the teach pendant, put it to the other one, modify the code. Once the coding is done, you no longer need it. So all of them can be interconnected through automation systems, and then all can be synchronous, all can do perform a job and do multiple things. We'll discuss very much in detail. So this is how this controller box looks like when it is open. When it is open. So what do you see here? This is the first thing which might have taken your attraction. What it is, it looks very much like a PC. Yes, it is a PC. It is nothing but a standard PC, personal computer, but it is ruggedized to industrial standards. It is IP protected, maybe dust protected, maybe vibration, temperature, those things are protected, and it is very, very rugged. Got it? Some IOs are there, standard monitor cable you can see networking cable. It has some special cards which are there to do communication with the servo drives, servo motors that you could see on the robot. Those motors are run by these servo drives, and there are some safety circuits, control circuits. This is standard industrial IOs, input and output system, which you could see. Got it? And this is a standard UPS, so that it can allow, when power failure is there, it allows this robot to automatically shut down in safe mode. It doesn't do any disaster, right? It saves all the current location, it shut down safely, and this is connection for external switches that you have seen. So this is what it goes inside a standard industrial robot controller. So this is which is there in the controller. It has a IPC, industrial PC, with real-time operating system like VxWorks, Windows CE embedded, so on and so forth. There are many others. It can be some proprietary OS also. It has servo drive, as I have shown you. These are the servo drives. Backup battery you have seen just now. Input and output module. This is here. This is to control the grippers which are there, if it is electrical or pneumatic gripper. That is to operate the valves if it is pneumatic. If it is electric, it can directly switch on the solenoids or something like that. Sensors, that is to take the data from the sensor also. You need IO card. Safety circuits. Power system, it has a power system. Normally they are a part of this also, because you may have a three-phase supply, which is converted to DC, and DC again converted to a synchronous AC control, so that you run, that is not much required for this particular course. That is required to run any AC synchronous servo motor. So it has a inverter type of drive, so that is there. Power system is there. Cable connectors, definitely it is there. All bulk cable connectors are here, all IOs, so that this cabinet remains sealed. No dust can get in, no even ingress protections are there. Okay, so dust, sometimes water also, some paint spray, it can be located in a location where you have plenty of paint sprays. Data communication wire, Profinet, DeviceNet, Profibus, EtherCAT, these are some of the standard industrial communication systems. Over here it is a standard EtherCAT connection which you see, the green wires, these are communication. It is very much like Ethernet. What is there in your computer, RJ45 cable, this also runs on RJ45. If at all you feel difficulty in getting anything, you can get in between. Yes, now I would open a bit for discussion now. For 5 minutes, not much. Yes, please. Before I get into technical specification. Yes, anyone has any query can get in now.